President, no! Emergency meeting!
There's been an incident with the president. Wyatt.
Hey guys.
Secretary August, please explain the situation.
Hey, for those of y'all that are new, come gather around. Let me let you know what's happening. So, our president Wyatt Luker, he ate something a little nasty. We don't know how he got it yet, but we gotta get him safe. So, he drinks this water. This is how we think it went down. Drinks the water. Pill goes into his system. Not happy with his tummy. You know what happens? It leads to a coma. Our president's in a coma. So, what my team is gonna do is we get our Shrinkinator 5000, which is over there in the lab, and we shrink down the Toyota 4Runner right over there, and our mobile laboratory. Now, after we shrink it, we go magic school bus style straight down Wyatt Luker's throat into his tummy. We set up our mobile lab. That's us right there. So, when we're in the lab, what we need to determine is the concentration of acid A, which is the stomach acid. We need to keep that. And acid B, which is the foreign substance. Labeled right here. Now, what we're going to do is keep acid A and neutralize acid B. Hey, y'all. Before we head on over to the lab, this right here is Project Finkel. Finding intestinal knowledge in laboratory experimentation. To the lab!
Okay, the purpose of this experiment is to determine the concentrations, pH, and pOH of the acid A and acid B through titration.
2, 1.
Everybody, let's get safe. So, in the lab, we had gloves, goggles, and aprons on to prevent contact of harmful chemicals with the skin. We also did the lab in groups of 3 or more to make sure there's no error, because we had a lot of different opinions working on it at the same time. We were careful with any glassware, such as the beakers, the burette, and other stuff like this. We made precise calculations and, very carefully, meticulous, because, that's what we're all about. Anyways, let's say why.
Stay safe out there.
Titration is a laboratory technique used to determine the unknown concentration of a solution by reacting it with a solution of known concentration. The known solution is slowly added to the unknown solution until it reaches an equivalence point, the point at which the titrant neutralizes the analyte, meaning the moles of acid and base are equal. To visually detect this, an indicator is added to the solution that changes color at or near the endpoint, which really coincides with the equivalence point by measuring the volume of the titrate needed to reach the endpoint, and using the balanced equation, the concentration of the unknown solution can be accurately calculated.
In the garage!
When I dance, they call me Macarena, and the boys they say que soy buena. They don't want me, they can't have me.
1-2 step in a box. 1-2 step in a box.
Here guys, this is our lab. We're gonna shrink ourselves and get into the lab and then put it down Wyatt Luker's throat. The president will be saved because of us. We'll save the president!
For Wyatt!
For Wyatt!
To the garage, guys!
I got a ticket for the long way round. 2 pounds whiskey for the way. And I said, I'm yours, company. Something when I say, when I'm gone. When I'm gone. You're gonna miss me when I'm gone. You're gonna miss me by my head. You're gonna miss me everywhere. You're gonna miss me when I'm gone. When I'm gone. When I'm gone. You're gonna miss me when I'm gone. You're gonna miss me by my walk. You're gonna miss me by my tower. You're gonna miss me when I'm gone.
Step number 1. 2 clean burettes were set up. One was used for the acid, one was used for the base. The acid burette was rinsed 3 times with the acid used. Same was done with the base. Step number 2. The first burette was filled to a point just above the 0 milliliter calibration mark with the acid of unknown concentration. Step number 3. Some acid was released from the burette to remove any air bubbles from the step and lower the volume to the calibrated portion of the burette. Number 4. The 4.5 milliliters of acid was dropped into a clean Erlenmeyer flask. Number 5. The volume of the acid in the burette was recorded to the nearest 0.01 milliliter. Number 6. The initial volume reading was subtracted from the final volume reading. In that, there was the exact volume of the acid released into the flask, recorded to the nearest 0.01 milliliter. 3 drops of the appropriate indicator were added to the flask. Step number 8. The other burette was filled with a standard base solution to a point above the calibration mark.
Some base was released from the burette to release any air bubbles and lower the volume to the calibrated portion of the burette.
Good.
The volume of the base was recorded as the initial volume to the nearest 0.01 milliliter mark. The Erlenmeyer flask was placed under the base burette with the burette tip extending into the flask. The base was slowly released from the burette into the flask while it was constantly swirled. The indicator faded while swirled.
Next one.
When the color stayed for longer periods of time, the titration was nearing the endpoint. The base was then added drop by drop, slowly. The equivalent point was reached after a light color remains after 30 seconds of stirring. The initial volume of the burette was subtracted from the final reading. This was the exact volume of the base released into the flask. It was recorded to the nearest 0.01 milliliter mark.
Next, we repeat the same trial 2 more times.
Yep.
This is acid A, hydrochloric acid, which is white Lucre stomach acid. This is our chemical equation and the chemical formula. This is our initial volume for 3 trials. This was the final volume, the volume used, and then we averaged it to get that number. For the base, we did the same, initial volume, final volume, volume used, and that was our average number for base used. This is acid B, sulfuric acid, which is the thing we want to cancel out. We want to neutralize this. This is our base. This is our initial volumes for the acid, final, this is our final. This is subtracted, and then initial, final volume, volume used, and this is I don't know.
Our titration results show that the unknown concentration of the acid was very similar to the data collected by other scientists looking to save white, which suggests that the procedure was accurate and consistent across all the scientists doing the work. The consistency supports the reliability of the method used and indicates that most of the scientists followed the procedures correctly. Some sources of error may still have affected the final values. Personal errors may have included misreading the burette or adding too much titrant past the endpoint. Systematic errors could have resulted from improperly calibrated equipment, such as a dirty burette or inaccurate markings or glassware. Random errors may have occurred due to slight variations in timing when observing the indicator color change or air bubbles in the burette tip affecting volume measurements. Despite these potential issues, the closeness of the results across the class strengthens confidence in the data and the calculated concentration, and overall, white was saved.
Thanks, guys. Don't know what I would do without you.